Okay, so I actually recorded the second, it's right here, the matrix solutions 6.1. Was it 6.1? Yeah, 6.1 part 2. And I don't know, there's something wrong with the recording. So I'm just going to do it again. That's the work for it. It'll let me zoom out. I'm actually going to go ahead and delete all of this, and we're going to solve this system, okay? I definitely wouldn't just talk through this right here because it definitely wouldn't be understood then. Okay. So, let me delete that. Let me go ahead. It's so crazy. Usually we're on like 54% or something. That's how zoomed in we usually are. And look at that. Big difference. Okay, so we have already done a video talking about row operations and how you can apply those within your matrices so that you can actually solve them, right? Our goal, whenever it says to use the Gauss-Jordan elimination method, which a problem should state which method to use, just make sure that you actually do those steps. And that you don't just solve it in whatever way you know how, okay? You need to actually use all of these steps to solve one of these systems. Our first step, y'all, is to write it in an augmented form, right? An augmented matrix. And all that means is that we're going to bring down all of the coefficients and put it in a matrix form. Our goal, let me go and write this. Our goal is to get our matrix into row reduced echelon form, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. When you have that, the answer that you get for your constants, those are your actual x, y, and z values. I don't know if it says it for sure, but in your homework, if you do like view an example, it may tell you at a certain point that you could go ahead and solve using substitution, and that is completely fine. I think continuing with this method all the way to the end just reinforces the steps and would help you more on an exam and on your homework, okay? So let's go ahead and let's write this in an augmented form, which, remember previous video, we just write the coefficients and then we also have our constants. We no longer are working with our variables, okay? So an augmented matrix is going to be 1, 1, 1. We have our line. We have a 3. We have 2, 3, 7, and 0. We have 1, 3, -2, and 17. Right? So looking at this, I know that I need to get it into row reduced echelon form, and that means I need row 1, column 1 to be a 1. Looking here, right, honestly, they're kind of starting out giving us an easy-ish problem because row 1, column 1 is already a 1. Y'all, these are called pivot points. What we do is once we turn our diagonals into 1s, we then can use them to create the zeros that we need for the rest of the column. Okay, so technically they're called pivot points. This is what I would need to turn into a 1. It's already a 1, right? So there's no need to put a square around that. I've been circling what I need to turn into a 0. That way I just kind of know both of the steps that I'm doing here. I need to look at my row 1 and let me just, I can do this. I need to look at my row 1 and see what can I do mathematically so that I can create an additive inverse so that I can combine it to either of these two rows and actually turn that 2 and that 1 into a 0, right? So because it's a positive 2, I need a -2. And the reason why I'm using my pivot point is because it is the number 1, right? Mathematically, I can very easily multiply row 1 by -2, combine it to row 2, and then that 2 just turned into 0, right? So honestly, again, I'll probably say this a million times, but it is literally sheer manipulation. Okay. You do what you need to do to have your pivot point, and then you do what you need to do mathematically to combine it to other rows to create your zeros. And then you move to column 2. You do the same steps. Move to column 3. Do the same steps. Okay. So let's go ahead and let's write what the row operation is that we would apply here. I know that I need to cancel that positive 2. So I'm going to take negative 2 times row 1. Then I'm going to multiply it to row 2. What this does is this is going to give me a new row 2. Okay. And then I noticed that I also have this positive 1 right here. I need to combine that with a negative 1, which would mean I would just take negative row 1, combine it with row 3, and that's going to give me a new row 3. I'm going to actually do this work kind of off to the side. Did it actually touch it? Yeah. Let me go ahead and do this. I really don't want it just there. If y'all saw my actual work, it's written slightly different than what I do here. That might be why I kind of paused. I'm just like, what's the easiest way to set this up for everybody, Let me actually move that up a little bit more. Okay, we're going to go and do this right here. I'm going to do this work, and I'm going to do this work. Okay, I'm literally going to fill in everything that I need, then perform the arithmetic, and the values that I get will be my new. For here would be my new row 2. For there would be my new row 3, correct? Okay, so I've always said this, y'all, but if you see a pattern, feel free to go ahead and follow that pattern. Mathematics is filled with patterns, and I think understanding it and doing well in math is recognizing and understanding those patterns, right? So let's go ahead and do that first row operation. What we're going to do, if y'all don't mind, look right here. I'm going to have a new row 2, and I'm going to have a new row 3, correct? What row does not change? Exactly. My row 1 is going to be unchanged even after I do these row operations. So what you can do is go ahead and just bring it down. Okay, it's just one less thing you're going to have to write in just a second. So let's perform these row operations. I have a negative 2 times row 1. Okay, ooh, that's my row 1, correct? 1, 1, 1, 3. So I'm going to multiply negative 2 times row 1, 1, 1, 1, 3. Right, then it told me to add row 2. That's row 2. So I'm going to add 2370. This is going to equal, I will get a new row 2. The answers that I get here are going to be my new row 2. Okay? If y'all are okay with it, I'm going to go ahead and write what I need on this second row operation. That tells me I'm just going to take a negative row 1. Right? Those are all positive values in row 1. So I can just simply add the negative in front of them. I'm trying to fix my bracelets. We get a negative 1, negative 1, negative 1, negative 3. I'm going to add these values to row 3, which is right here. And that's a 1, 3, negative 2. Oh no. 1, 3, negative 2, and 17. This is going to give me my new row 3. Going back to that first row operation, if you do 2 times 1, you get 2. Signs are different, so it's a negative 2. Negative 2 plus 2 gives me 0, which is great because that's what I wanted, right? 2 times 1 equals 2. Signs are different, so it's negative. Negative 2 plus 3 would give me 1. And then if you do 2 times 1, you get 2. Signs are different, so it's negative. A negative 2 plus 7 is going to give me 5. I need a new pen. 2 times 3 is 6. Signs are different, so it's negative. A negative 6 combined with a 0 is just negative 6. So this is my new row 2, correct? That's my new row 2. And that's row 2, right? So the answers I just found go here, okay? And those answers are 0, 1, 5, negative 6. Okay, so let's do the second row operation. If you do negative 1 plus 1, I get 0. Negative 1 plus 3, subtract, keep the sign of the larger. Negative 1 and a negative 2 would be an add and keep. And then negative 3 plus 17 is subtract, keep the sign of the larger. And so now this is my new row 3. These values are. And this is row 3. Okay, let's go ahead and write those values in there. We have 0, 2, negative 3, 14. Okay, so I have finished. I have done what I set out to do for this first column, right? Do you notice how this is row echelon form for column 1? I still need to do column 2 and column 3, but I'm done with that column, okay? Let's go ahead and let's move on to column 2. I know that I need row 2, column 2 to be a 1 because that's my pivot point. The good thing is it's already a 1, which is great. So I know I don't need, y'all, killing me. I'm killing me, Smalls. There we go. I don't need to turn this into a 1 because it's already a 1. So now what I'm doing is I'm going to turn this into a 0 and I'm going to turn this into a 0, okay? So the row operations I would need there, row 1 needs to be combined with a negative 1. Row 3 needs to be combined with a negative 2. So I'm actually going to take what I need, which is a negative 1. I'm going to create that with my row 2, right, by making it a negative row 2. I'm going to add that to row 1, and what I get is a new row 1. And I'm going to take, literally didn't even do anything. Like all I did was breathe. That's it. Just breathed. Oy vey. Okay, so now I'm also going to take a negative 2, row 2 plus row 3 will give me a new row 3. I actually want to put this here the same way we did. Of course, I think every time I paste it, it kind of goes a little to the right. We're going to cut that. Let's see if we can't get it to, of course we can't. I'm just going to write it again, y'all. That's going to aggravate me. Okay, so let's do our row operations right here. What I have is a negative row 2 plus row 1 will give me a new row 1. If you notice, I really just need to perform the row operation kind of to the side. Me writing it under here is just like, hey, what do I need? And then I'm bringing it to the side. You could just bring it over to the side. Okay, y'all? I usually, well, it doesn't matter what I do. We have a negative 2, row 2, plus row 3, gives me a new row 3. Okay, so I'm looking at the matrix that I just finished with right there. I'm going to do a negative row 2, which is going to be a negative 0, negative 1, negative 5, and a negative 6. I'm going to add to that row 1, which is 1, 1, 1, 3. And what I'm going to get is my new row 1. Here I'm going to take negative 2 times row 2, which would be negative 2, 0, negative 2 times 1, negative 2 times 1. What? It's row 2. I was looking at the previous problem and I got confused. 0, 1, sorry, now 5, right? Here's row 2. Negative 2 times 0, negative 2 times 1, negative 2 times 5, and now negative 2 times a negative 6. I'm going to add to that row 3, which is 0, 2, negative 3, 14. So 0, 2, negative 3, 14. The answers I get here will be my new row 3. So starting that first row operation, I've got 0 plus 1, which is just 1. I've got negative 1 plus 1, additive inverses. I needed that. That's good. I did that on purpose. Negative 5 plus 1, signs are different, so you subtract, keep the sign of the larger. That's actually going to be a positive 6 plus 3, which is going to give me a 9. And then on the second row operation, I have 0 plus 0, which is 0. And then I have negative 2 plus 2, which is 0. Then I'm going to have 2 times 5, which is 10. Signs are different, so it's negative. Combine that with a negative 3. I would add and keep their sign. And then 2 times 6 is 12. Signs are the same, so it's positive. Positive 12 plus 14 gives me 26. Okay, so let me go ahead and draw my matrix right here. I noticed that I got a new row 1 and a new row 3, which means row 2 did not change, which means I could just go ahead and write row 2 right here. And now let me look. This right here is my new row 1, right? And that's going to be my new row 1. And the values that I got here are 1, 0, negative 4, and 9. And then if I look right here, JK, these values are what make up my new row 3. Row 3 is right here. And those values are 0, 0, negative 13, and a positive 26. Okay, so now please recognize that I am 2/3 of the way done with my row reduced to echelon form, correct? The thing I would do now is this needs to be a 1. Use that pivot point to turn those into zeros, and then you're done, okay? So let's go ahead and let's look at this matrix. I do need to get my pivot point first. And so this means that I need to turn this into a 1. It's not a 1. The previous steps, it has been a 1. The way you're going to turn a negative 13 into a 1 mathematically is to actually divide by negative 13. So the row operation I'm going to do is going to be row 3 divided by negative 13. Doing this is going to give me a new row 3, okay? So let's actually come right here and let's do row 3 divided by negative 13 gives me, what is that? A new row 3. Okay, so what I get is this is row 3. I'm going to divide everything by negative 13, right? So I have 0 divided by negative 13. I just said divide everything by 13, but it's a negative 13, y'all. I have another 0 divided by negative 13. I have a negative 13 divided by negative 13. And I'm going to have a 26 divided by, I'm going to do this, y'all, because I don't need much room for these. Negative 13 divided by negative 13. And then I have a 26 divided by negative 13. Y'all, we're able to do row operations because these zeros won't be affected once we move on. The ones we're using to change things, so it also won't be affected. Hopefully that makes sense because that's a big part of solving these. If you look at 0 divided by negative 13, 0 divided by anything is just 0, right? So doing this math didn't change that value, which is good because it has to stay as what I made it, right? I made it a 0. It needs to stay a 0. 0 divided by negative 13 is also 0. 13 divided by 13 is 1. Signs are the same, so it's a positive 1, which is what I needed. Not a negative 1, a positive 1. 26 divided by 13 is 2. Signs are different, so it's negative. So going ahead and writing my matrix, the only thing that changed was my row 3. So what I can do is go ahead and write down my row 1 and my row 2, correct? Nothing mathematically altered them. So I have 1, 0, -4, 9, 0, 1, 5, -6. And then now these are my new values, right? Those are going to be what makes up my row 3 is here to here, right? And I went in that order, go down here, and then go down here. This is my row 3. And so what I'm going to do is I'm going to take those values 0, 0, 1, -2. Okay, and so I'm almost done, y'all. You may notice that the help, like I said earlier, may tell you that at this point you can, if you wanted to do substitution, it's totally fine. I prefer Gauss Jordan. I just love it. And so, again, I think this will help you with your homework and your exams. I would just finish the problem. It's just one more step, right? Substitution is going to require, I think, a little bit more thought process. I did what I needed to do to turn that into a 1, right? Now what I need to do is actually turn these into zeros. And so because that's a -4, I need to combine it with a 4. So what I would do is I would multiply 4 times row 3 plus row 1. That's going to give me a new row 1. And I have a 5 right here. So what I need to do is combine it with a -5. So I would actually take -5, multiply it by row 3, add it to row 2, and that's going to give me a new row 2. Y'all want to try this one more time? Let's copy it. Boom. Up. Okay. So let me go ahead. I notice sometimes I write it first, sometimes I wait. Let me go ahead and do my matrix. So I notice I'm going to have a new row 1 and I'm going to have a new row 2, but what does not change is this row 3. The reason why it does not change is because that's my pivot point. That's what I'm using, right? So because it doesn't change, I can go ahead and write my row 3. I kind of can't get out, like, let me zoom a little bit. I need to be able to see that matrix, right, to perform this operation. So let's go ahead and do, I know there's 4 values here, right? So I'm going to do 4 times something 4 times. My row 3, I know this is row 3, sorry. I circled this a second ago. These all have 4 values. This is just what my point was. 4 times row 3, it's going to be 0, 0, 1, -2. Add to that row 1, which is 1, 0, a -4, and a 9. This answer right here is going to be my new row 1. Let's go ahead and do -5 times row 3, which is 0, 0, 1, -2. I'm going to add it to row 2, which is 0, 1, 5, -6. This answer is going to be my new row 2. So first operation, 4 times 0 is 0. 0 plus 1 is 1. So if you notice, this right here is coming from right here, and it didn't change its value, right? It's still a 1. That's why all of this whole process works. 4 times 0 is 0. 0 plus 0 is 0, which is great. Didn't change that value. Awesome. 4 times 1 is 1. If you do 4 minus 4, you get 0, which is what I wanted. 4 times 2 is 8. Signs are different, so it's negative. If you do a -8 and a 9, what you end up getting is just a +1. Okay? Try not to grab my pen wrong. Okay, y'all. So I think I've been using green a lot. This is my new row 1, right? And this is row 1. Hi, Allie. Go lay down, Allie. Come on. Get up here. So now let me go ahead and do the other row operation. -5 times 0 is just going to be 0. 0 plus 0 is 0. Negative 5 times 0 is going to be 0. 0 plus 1 is 1. 5 times 1 is 5. Signs are different, so it's negative. Combine that with a positive 5, you get a 0. 5 times 2 is 10. Signs are the same, so it's positive. 10 minus 6, right? That's going to give you 4. And what I have here, this is my new row 2. This is row 2. So now let's actually go ahead and fill those values in. Row 1, I get 1, 0, 0, 0, 1. Wait, did I say too many? 1, 0, 0, 1. Awesome, looking good. Row 2, 0, 1, 0, 4. 0, 1, 0, 4. Do y'all notice that was supposed to be red? Do y'all notice that my diagonal, those are my ones, so it's in row reduced echelon form. Now, if you move on to like linear algebra, these are called top and bottom triangles. So once you get to one triangle, you can pretty much solve the problem. It just gets so much fun. Okay, so y'all, you're done with this problem. Okay, I showed you that if you are in, I literally didn't even do anything. Where am I? It's so funny. I literally showed y'all that when you get to row reduced echelon form, I'm just going to write you right here then. You don't want me to write anywhere else. Right, so that's 1, 0, 0, 0, 1, 0, 0, 0, 1. The value you have here, that's your x, y, and z. So right here, this tells me that my x is 1, my y is 4, and my z is negative 2. I feel like in this section doing Gauss-Jordan, won't even let me do anything. There we go. I think a better way would just be x equals 1, y equals 4, and z equals a negative 2. If it just asks for you to solve the variables, this is solving for the variables. If it asks you to find the solution set, that's when we would use the ordered triple, okay? No idea how long this video took. I still have like 3 more examples to do. They're a little bit smaller, so they'll be easier. But if y'all have any questions, make sure you let me know, okay? Thanks. Bye.